Hello there and welcome to my workshop. The previous video to this, we constructed a small test job and tool paths for a CNC machine. A CNC router, in this case a 6040. It really doesn't matter about the size of the machine, provided it's large enough to take the piece of work. But in this case it's a 6040. During this video I'll be giving you some tips on what you should be looking for in a 6040 as well. Okay, so now we're going to start to set up the CNC router to machine this job. So we're going to start off by positioning the work on the bed. Okay, so what I normally do to position a piece of work and to find the zero point of the work, that's the start or the orientation start then of the piece of work, of the job. We had the orientation in the center of the work. So everything started from the center of the work because it's only just a pocket. And we did say that the material size was 100 mil by 100 mil, 4 inches by 4 inches. But it really doesn't matter the size of the material. I've just marked the center on this piece of material because it's only a test piece. So we're going to position this on the table and clamp it down, and we're going to use a fairly pointy tool to find the center of the material. Fairly accurate, within sort of a half a millimeter is fine when you're dealing with wood. As we're on the subject of tools and pointy tools, this is a tapered ball mill. Now I'll show you another one of those. I've got one here. So that's a tapered ball mill. Okay, it's about an inch and a quarter long. Okay, and it's a 2 mil ball on the end. Okay, I recommend these cutters. They don't tend to flex very much, which is what you want, and they do a very good cut. So that's one tool I would recommend. And this has a 1/4 inch shank. Okay, now that's very important. Now if you buy a CNC router with a 1.5 kilowatt rotor, the largest size shank tool you're going to get in it is 6 millimeter. I would advise you, for the extra $100 or whatever it's going to cost, you're looking at just about $100 extra normally, for an upgrade to a 2.2 kilowatt. That's what this is. Now, a 2.2 kilowatt will take a shank of 13 millimeters, half an inch. So that means your tool library then that you can use in your router greatly expands. For example, we're going to be using this tool. This is a 1/4 inch 2 flute end mill, pretty standard end mill. So that would be the largest size in the 1.5 kilowatt. So you're limited to something between, this is an engraving tool, very sharp tool, it's an engraving tool, and this is 1/8 of an inch shank. So that would be about the smallest tool that you're going to get in to this. So if you upgrade to a 2.2 kilowatt, you can fit in there anything from 1/8 of an inch to half an inch shank. So that means like this is a 8 millimeter extended 3 flute cutter. Very good cutters they are. These types of cutters, they're like a fly cutter. that you use to machine away a lot of material. If you've got a large job, you can go in with a roughing cut and machine a lot of material away with these type cutters. All right, if you can imagine, if you had, you know, a cutter surface area of that size, which is 1 inch, on the end of a shank that size, you'd have to be very careful taking your cuts very slowly. You'd have to be very particular, and you wouldn't be able to go more than about 1/8, well, probably 1/16 of an inch deep only, because it'd snap it off like a carrot. These are normally made of tool steel. Although tool steel is very tough, they're very brittle, and they will only take so much flex before they'll just ping, snap straight off. So, and I would recommend you get a tool like this. This is 1 inch or 25 millimeter facing cutter, normal standard router cutter, or one like this. Now this one is a 19 millimeter or 3/4 inch ball cutter. Okay, I use that one quite a bit too. I recommend that one. That's a V-bit carving tool. Okay, one of those. That's a smaller ball mill. This one is, let me see, I think that was about 5/8. What am I talking about, 5/8? No? 3/8. I got a measuring tool here, I'll measure it. Tell a fib, that's 1/2 inch. 13 mil. Same for that one. Highly recommend that. 3 flute, because that one you can cut timber or you can cut aluminium with. Okay, 3 flute, extended mill. 1/4 inch ball mill. Recommend. A lot of work for that one. And for a finishing tool, you could either buy one of these, which is a tapered 2 millimeter, or you can buy these very small 2 millimeter 1 flute cutters. Just to give you one idea, this is solid carbide. Expensive tool. That particular tool is going to cost you about $60. These cutters, for a set of 10 on eBay, you're going to pay about $12, maybe $2 delivery. So it's, you know, and these will bust very easily. These won't bust so easily, and being solid carbide, this will stay sharp a long time. So that's a rundown of some of the tools that you probably should be looking at. You can buy all of these on eBay if you're prepared to wait. Other than that, your normal tool stockists will sell you these. Okay, so what we're going to do now is line our piece of work up and set up our 0, 0 position. In other words, tell the machine where the X and Y point is on this material. Then we're going to swap this tool out, put the 6 mil end mill in, and find out the Z. Okay, and we've got an automatic Z tool for that. Okay, what I normally do is I actually use the T-slot ways to give me a bit of a guide. I know this is straight, so I just line it up there carefully. Put the clamp there, support the clamp the other side. Now this clamp should be either flat or pointing down, never pointing up. Okay, so I use the same size material here as here, and keep it nice and even, and just, that's all it needs, that end, and the same this end. Okay, nice and firm. 2 is all you need. There's not too much sort of lateral forces on the tool to actually move the material. It's vibration that moves it more than anything. Okay, so we're going to now start the CNC router up, and we're going to use Mach 3 to position this tool over that X. Okay, I'm going to use the arrows now on my keyboard to move this, and we're going to send it down a little bit. Close to the material, and then just jog it very, very slightly. Oop, too much. It's okay for the X. Now the Y. That's pretty good there. So I'll just show you what I'm going to do now in Mach 3. So I'll zoom in slightly for that. So all I'm going to do, I'm going to position the cursor over the X and go press it. So it'll all go to 0. Press the Y, all go to 0. We're not interested in the Z yet. In fact, I'm going to take the Z up, because I'm going to change the tool out. I'll show you how to change a tool. Okay. So we're going to spanner on the shank, or the actual shaft. One on here, and slacken it off. Just about got that one out. So that's the tapered ball mill. No need to have it sticking out too long. That's about right there. Now you don't have to over tighten these, it's just nip it up firm like that. Now what you do, you get your Z height tool setter, put on there, and in Mach 3, and I'll just take the camera down and show you this. Right there in about the middle of the screen, auto tool set. So we're just going to press that, and I'll quickly put the camera back to show you the tool coming down. Okay, so in the middle of the screen you can see the auto tool set here. I'll see if I'm going to be quick enough to press this and then turn the camera back. There we go. And it's auto tool setted, I think I'd say better than that. And it's set the correct height for the material. Okay, that 29 millimeters there is made up of the height of this plus the 9 millimeters that we set in Fusion 360. So if you remember when we did the program and in the settings, when we chose the tool, the settings for the offset of the tool above the material was 9 millimeters. Well, this tool setting device is 20 millimeters, which is set into Mach 3. So Mach 3 has come down, touched off on this, and added the 2 up and displayed the 2. So Mach 3 knows exactly how far it is off this material. So now we have the X, Y and Z set. There's one little job we've got to do. We've got to reconfigure Mach 3. Now when I say reconfigure Mach 3, I meant actually regen. So it regens all the tool paths just like that. So in other words, Mach 3 checks itself to make sure that everything is correct within the program to do this cut. So now we're going to do the cut. There's our pocket in our piece of work. Just give it a quick measurement. Can you read that? 49.9. Well, actually, it's just gone to 50. There you go. So that is exactly 50 millimeters, which is around about 2 inches. So there you go. Beautiful, clean cut. No vibration marks, no tool chatter, and you'd see tool chatter on this surface here. It's absolutely beautiful, clean cut. This will just come off with a bit of emery, bit of paper, and clean up really well. And it'll cut this in aluminium as well. But a word of warning: not all machines that you see for sale are like this one. Now I'll take the camera off its tripod and I'll run around this machine and I'll give you some pointers to look for. Okay. You'll appreciate that for sale on the internet, no matter where you buy it from on the internet, there are machines worth buying, and unfortunately 90% of the machines that you see for sale are not worth buying. And there's an old saying, you get what you pay for. This machine in the 3-axis, this is actually a 4-axis machine. The 4th axis is down under here because I'm not using it. This is the 4th axis for it. Ooh. Very heavy, very solidly built. So that is a decent 4 axes. Three axes machine, you're looking at a minimum of $2,000 US. 4 axes machine, that's going to add another probably $500. This is not a toy. Most of the machines you see on the internet are made, the gantry and the frame is all made of extruded aluminium, or in some cases plastic. 3D printed, I kid you not. CNC routing is all about rigidity. If you haven't got a solid chassis then to hold this, you're not going to turn out very good work at all, and you're not going to be satisfied at all, and you're going to be throwing your money away. Minimum requirement: solid aluminium, not extruded or box section. This is 20mm solid aluminium plate for the uprights, cross, and everywhere else. Same here. 20mm aluminium plate, solid. And another thing, linear round rails for the y-axis. Okay, linear round rails. What a linear round rail is, it has its own chassis rail, so it doesn't flex. It's not too bad up here. These are linear rails, okay, or just like ram tubes on a hydraulic ram. That's what these ride on. Up here it's okay, but on the bigger machines you even want linear rails up there as well. On these smaller machines, must insist on linear round rails for the y-axis. The bed. Now this is set up for coolant, and this is made of 16 gauge steel, fully welded and plated. Then the bed is laid on that and waterproofed. That gives you a solid bed. It won't flex and it won't vibrate. If you notice, this was cut in this wood, and I was very conservative with feed rates. No vibration. If you have a bed or just these aluminium extruded, the bed's aluminium extruded, and screw something onto it, the bed vibrates like this. If you just have the extruded aluminium, you've got to have a backbone. So insist on that. The drive motors, NEMA 23s or equivalent. Anything else, quite frankly, just won't do. The control unit. Now I'll show you a decent control unit. I'll just show you this one under here. This is an aircraft grade electronic control unit. This is what you pay the extra money for. It's not going to break down on you. It's fully enclosed and earthed. You've got to make sure that the electronics meet your region in your part of the world's minimum regulations. And last but not least, insist that the machine is set up with a USB controlled Mach 3 board in the controller. It's all set up for Mach 3. If the company won't do all these things for you, including 2.2 kilowatt water cooled not air cooled, water cooled. It'll last you 3-4 times as long. The company you're buying from won't do these things. Run away. Do not buy from them, because a reputable company will do these things for you. I can't say it any clearer than that. If you import one of these machines, first of all, there's the outlay to buy the machine. This machine with the 4th axis was approximately $2,500 set up for Mach 3, as you see it here. Then there's the freight cost, $600. Then when you get it to your port of entry, then you have your duty and excise and handling fees and delivery fees, your end, on top of that. So this machine to your door, you're looking at possibly $3,800 US, maybe a little bit more now, because there's other regulations in certain parts of the world on imports that you're going to pay a little bit more again. So, you know, I've given you a good idea now of a 6040 machine, a good one. Anything less, you're going to be throwing your money away. Unfortunately, I can't give you the maker of this particular machine because they've gone out of business. I've given you the tools to go out there and make your own decision about purchasing a machine. So I hope it's been a help to you. And I hope the previous video to this on Fusion 360 and this video has also been a help to you. So for the rest of this year we will be continuing and probably stepping up, doing more and more videos of Fusion 360 and CNC routers and mills and lasers, and we'll throw in a bit of wood turning as well. So thank you for joining me, and if you've liked the video, please press subscribe and like and pass it on to your friends, because that's how the channel grows. And well, it's bye for now.